Good morning to all the students of class 8. So today we will start the new chapter, chapter 4, that is energy. Okay. So let's start and open your books and take out your page number 64. Okay. See, work and energy are two very commonly used terms in our daily life. We do different activities like reading a book, watching TV, playing with our friends, doing our school work, etc. In all such activities, we consume energy and we say that we are doing work. So, the rate of doing work is known as power, and work is said to be done when a force acting on an object changes the position of the object. Okay. So, from here, we can say that work is said to be done on the applying force of an object in the direction in which the direction of the force. Okay. But suppose a girl is reading a book. Is she doing work? No, because neither she is applying any force nor is there any displacement. Okay. But when a cricketer will hit the ball and runs between the wicket, is he doing work? Yes, he is doing work because the cricketer is applying a force and there is displacement also. So, understand the difference? Okay. Next, see, these are the examples and you have to just overlook it. Okay. And next, see conditions for doing work. Conditions from doing work. From the above examples, it is clear that following two conditions must be fulfilled or mechanical work to be done. A force must be applied on an object. The object must move through a certain distance in the direction of the force applied. These two conditions must be there for doing a work. Okay. So you have to read it. Mark it where I have marked it. Okay. Next, go to page number 66 and see measurement of work. How to measure that how much work you have done. Consider an example. Suppose two boys are pushing identical cupboards 20 kg of mass on a floor. Boy A pushes the cupboard through a distance of 4 meter and boy B pushes the cupboard through a distance of 6 meter. And in this case, work done by a boy is B more because he has pushed the cupboard through a greater distance. He had pushed 4 meter and he had pushed 6 meter, so he had done the greater work. Okay. So consider another example, that let boy A pushes the 20 kg on a floor through a distance of 4 meter, but he will push 30 kg. So we will who will do the greater work? In this case too, the work done by boy B will be more because the weight of this cupboard is more than this cupboard. Okay. So we can explain it through W equals to Fs. F multiplied by S. That means F is the force applied and S is the distance moved in the direction of the force, that is 4 meter. Okay. So from here you have to learn mechanical work is done by given the product is is given by the product of the force acting and the distance moved in the direction of the force, that is W equals to F multiplied by S. Now SI unit of work. SI unit of work is joule and its symbol is J. Okay. The distance moved by the object in the direction of the force is W equals to F into S. That means 1 Newton into 1 meter. That is 1 Newton meter. 1 Newton meter equals to 1 joule. That can also be written as 1 J. And 1 kilojoule will be equals to 1000 joule. That means 10 to the power 3. 10 to the power 3 equals to 1000. You can write 1000 also and you can write also 10 to the power 3. Go through the examples. The examples are very easy. Go through the examples. Okay. Next, see page number 68. Energy. Energy is defined as a capability of doing work by an object or a person. Okay. So the SI unit of energy is joule. So 1 joule of energy is the energy needed to do 1 joule of work. That is 1 kilojoule equals to 10 to the power 3 joule. And 1 megajoule equals to, it will get double, that means 10 to the power 6. And here 1 gigajoule equals to 10 to the power 9 joule. Okay. And so the forms of energy will be mechanical energy, light energy, electrical energy, chemical energy, nuclear energy, heat energy, this types of. So we will learn today mechanical energy. The energy possessed by an object by the virtue of its state of motion and the specific motion and configuration even when it is at rest is known as the mechanical energy. Now, mechanical energy are of two types. Okay, kinetic energy and potential energy. So, the kinetic energy is the energy possessed by an object in its motion. You had already read in previous chapter only. The energy possessed by an object when it is in motion is called the kinetic energy. Suppose a a strong wind can uproot big trees due to its kinetic energy, or else kinetic energy of wind can be used to run windmills also. Okay, so the formula of kinetic energy is very important, that is half mv square. Half mv square, m is equals to mass and v is equal to speed. And something more, ocean waves and sea tides also possesses a huge amount of kinetic energy. It can be harnessed to produce electric energy. We all know that electrical energy is produced from the water only. Okay, so again go through the examples, because the examples are very easy. You have to just put the formulas and do the sums. Okay, next is potential energy. Potential energy, the energy stored in an object at rest due to its position or configuration, is called potential energy. And from here, potential energy are of two types: gravitational potential energy and elastic potential energy. Gravitational potential energy, the energy stored in an object due to its position even when it is at rest, is known as the gravitational potential energy. Suppose from you, if we will see this example, from this activity it will get clear. Okay, so the formula of the potential energy will be m into g into h, but m is equal to mass, g is equal to the gravitation, and h means height. Okay, so water stored in a overhead water tanks, we all see that possesses potential energy, because when a person lifts a hammer a high above, the work done by him against the force of gravity is stored as potential energy in the hammer. Okay, a fruit on a tree is hanging, a child sitting on the top of a slide. Okay, rocks resting on the top of a hill. These all are examples of potential energy, gravitational potential energy. And elastic potential energy is an object can also have potential energy on account of its configuration or change in configuration, and it is also known as a elastic potential energy. Okay, and again go through the examples and learn this difference between kinetic energy and gravitational potential energy. So we will read here up to. Okay, thank you students.